In today's class, we are going to talk about exponents and power. That is from class 8 maths book, chapter number 12. So, let us try to first understand the meaning of these two words, exponents and power. Okay, so suppose we write the number 2 into 2 into 2, suppose 5 times. Okay, sorry, uh, 2. Okay, so uh, if we are supposed to copy the same set of numbers somewhere else again, what we'll do, we'll end up copying this thing 5 times, and that really wastes away a lot of time. And especially suppose if you're having some kind of scientific work where you need to put the things in much more easier way, and where you don't even have to calculate at that instant, so there should be a way to represent this. Okay, so a number that gets multiplied with itself, okay, so that number becomes the base. Okay, and the number of times it is repeated, how many times was it repeated here? 5 times. So we'll write 5 on the top. This means 2 is repeated 5 times in multiplication, that is 2 into 2 into 2 into 2, that is equal to 2 4 8 16 32. Okay, so now in this case, this 2 is known as the base, and this 5 is known as the exponent. Okay, and this whole process of writing this thing is called as 2 to the power 5. So this thing, this notation is known as power. Got it? So 5 is the exponent, 2 is the base. The way of writing 2 to the power 5 is known as power in this process. Now, how does it help? You just don't have to like write 2 5 times or 100 times. You can simply write 2 to the power 100. The calculation part you can do later on also. Now, you must be thinking, oh, it sounds very simple. So what is 2 to the power minus 5? Can there be a minus 5 power? What does it mean? So 2 to the power 5 means 2 is multiplied 5 times. But 2 to the power minus 5 will mean what? 2 is divided by 2 5 times. No, it's the multiplicative inverse. Okay, so that becomes 1 by 2, that is multiplied 5 times. Okay, so we are clear with this, that anything to the power, when it is positive, it is a multiplication in the numerator, and anything that is negative becomes a denominator multiplication. Okay, so we can say 2 to the power 5 into 2 to the power minus 5 will ultimately be equal to what? Will be equal to 1. How will that be so? 2 to the power 5 into 1 by 2 to the power 5, which will be 1. Okay, so this was the basic thing about the notation itself, the positive and the negative. Now, there must be certain rules regarding usage of the power as an exponent. So, let us see rule number 1. See, the rules will sound very, very simple, but when you go to implement it, that is where you find the difficulty. I understand that, and once you go through this particular video, I think a lot of doubts will be cleared up right now. And if you have any further doubts also, or in a particular question, you can always write your questions in the comment, and I'll definitely be making a video on those kind of questions also, that solves that kind of situation, that you can do easily. Okay, so suppose a to the power 5 into a to the power m, and this is a to the power n. What is happening? The base is same, so the powers will be multiplied. The most simplest of the rule, a to the power m plus n. If we look at an example would look somewhat like this: 2 to the power 3 into 2 to the power 4. What will it be? 2 base is same, that is 2 and 2. Powers get added 3 plus 4, that becomes 2 to the power 7. Obviously, teachers do the easy one. So let me give another example. 2 to the power 3 into say 4 to the power 3. Now what will happen? See, the bases are not same, but we know 4 is what? 2 to the power 2, or rather 2 into 2. So we have to first convert this 4 as the base 2. Then we can do something about it. So this will be 2 to the power 3 into 4 will be 2 ka square, and to the power 3 remains. Now this particular rule also we are going to study in some time. So now the bases are same, 3 plus, now here the powers will get multiplied. That rule I am coming to in the next one. Okay, so this would be 3 2s are 6. So 3 plus 6, this becomes 2 to the power 9. Don't worry if you do not understand this part right away. Okay, don't worry about it. So the second rule, or rather a sub rule of the same setup, would be a to the power m by a to the power n. Now a to the power m, and this a to the power n can be written as a to the power minus n. So whenever we are bringing something from denominator to numerator, the sign of the exponent changes, and whenever we are taking down the numerator a to the power m to denominator, it would be a to the power minus m. Got it? So what will it be? It will be a to the power m, and as per the first rule itself, the powers are added. So basically m plus minus n. So overall it will become a to the power m minus n. Got it? Okay. So now let us have a look at the second rule. A to the power m to the power n. So it looks same as what we did just now. So it would be base, we'll write the same thing, and here it will be m into n. So it will be mn. An example we saw just now, suppose it is 2 to the power 2 to the power 3. So basically overall it's 3. So 3 into 2 is 6. So it will become 2 to the power 6. So now let us look at the third rule. This is also a very simple one. A to the power m into b to the power n, m. Now here the powers are same, the bases are different. So what will happen? The bases will get multiplied and they will be under the same power. For example, 2 to the power 3 into 5 to the power 3. So what will it be? 2 into 5 to the power 3. Okay, so this will be 10 to the power 3. Got it? So now let us come to the next rule. Next rule is a to the power m by b to the power m. What is happening? The bases are different, but the powers are same. So what we'll write? A by b whole to the power m. So these were the basic 4 rules. And the fifth one is, it's a kind of exception, you can say, that anything to the power 0 is 1. Another addition I can say, 1 to the power anything will remain 1. Now there is a slight condition over here. If m is positive, then also it's very good. If m is negative, then also it's very good. But however, if you have minus 1 to the power m, then things change a bit. Minus 1 to the power m will be 1 if m is even, because if you multiply minus 1 even number of times, it will be 1. and it will be equal to -1 if m is odd, because there would be a point where, like, if you are multiplying -1 into -1 into -1 three times, -1 into -1 becomes 1, and into -1 overall becomes -1 again. So that's why if it is odd, then it will remain -1. If it is even, then it's +1. Okay. So now let us see few questions that we can solve to further understand the chapter. Okay. So let us look at an example. For example, the question may be something like 2 to the power 5 divided by 2 to the power 8 whole to the power 5 into 2 to the power -5. Does it seem difficult or not? I don't know what can I make out of it. But what I can understand, this divided by this. Let us go by simple rules. Base is same and it is division. So we'll do 5 minus 8. How? It will be 2 to the power 5 divided by 2 to the power 8. So ultimately it becomes 5 minus 8. And the power outside, the exponent outside is 5. Okay. Into 2 to the power -5. So the next step I can write it as 2 to the power -3 into 5 into 2 to the power -5. And we can write 2 to the power -15 into 2 to the power -5. This would be what? The bases are same, so the powers would be added. -15 plus -5, which would be 2 to the power -20, which can also be written as 1 by 2 to the power 20. Okay. Had the answer been 2 to the power 10, suppose, I could have written it as 1 by 2 to the power -10. 2 to the power 1 by 2 to the power -10. Okay. So this thing was pretty clear. Okay. Now let us look at another type of question. There is a question like, find the value of m for a particular expression. Okay. So let us take an example. -3 to the power m plus 1 into -3 to the power 5 equal to -3 to the power 7. This kind of question may come in the exam. So what do we see? Bases are all same. So our first headache is over. Now what is the second thing we can do? Base is same, so -3. Powers are added. Why? Because there is a multiplication in between. M plus 1 plus this particular power, that is plus 5, that is equal to, what is it equal to? -3 to the power 7. Now this would be -3 to the power m plus 6, which is equal to -3 to the power 7. This implies now the bases are same, so the exponents can be equated. So we have to mention that since base is same, so exponents are equated. So m plus 6 is equal to 7. As for basic linear equation, what do we get? M equal to 7 minus 6, which is equal to 1. So the value of m is 1 in this particular case. Now let us come to another example, a more terrifying one. So 1 by 3 to the power minus half minus 1 by 2 to the power minus 3. Okay. This whole bracket close divided by 1 by 4 to the power minus 2. Can it get more difficult? Yes, of course it can, but as of now we'll go with this one only. So we can see 1 by 3 to the power minus 2. So what do? We can simply write this as 3 to the power 2. How? Because this is 3 to the power minus 2 in denominator. If we bring it to numerator, it becomes 3 to the power 2. So this fear is taken care of. Then we have minus 2 to the power 3. How? Same thing. 2 is in denominator, 2 to the power minus 3. It comes to the numerator, it becomes 2 to the power 3. So we have taken care of one of the monsters, divided by, again same thing, this will become 4 ka square. So the bigger things are already taken care of. 3 square is 9 minus 248 divided by 16. This implies 1 by 16, and that's the answer. Okay. Let us take little more different kind of question. In fact, it's an easy one. Uh, half to the power minus 2 plus 1/3 to the power minus 2 plus 1/4 to the power minus 2. Very simple. This becomes 2 to the power 2 plus 3 to the power 2 plus 4 to the power 2. This will become what? 2 into 2, 4, 3 into 3, 9 plus 4 into 4, 16. 16, 4, 20, 29. That's it. Now you all must be thinking, like in case, how we are getting half that thing as 2 to the power 2. See, this we can write it as 1 to the power minus 2 by 2 to the power minus 2. Okay. 1, since it is positive, whether it's plus or minus in the exponent doesn't matter, it will become 1. And this is 2 to the power minus 2. Now if we bring this thing up, it will become 1 into 2 to the power 2. Ultimately same as what we have already mentioned earlier. Now let us go through one or two more questions. And I think this is one of the easiest chapter if you understand the basic rules very well. In fact, all the chapters are easy if you understand the rules. Now let us look at another question. Minus 2 by 3 to the power minus 2, and this is 2. So always remember, try to go from inside to outside, or if you are very comfortable, then you take care of the exponents first. Whatever it is, you have to reduce the question to simpler form. Okay. So in this case, I'll multiply the exponents. So minus 2 by 3, it will become minus 2 into 2 is minus 4. And since the power, this exponent is in negative, I can safely make this thing as this way. What is the difference between this step and this step? The numerator and denominator changed their positions, and this exponent became, from negative it became positive. Now very important thing over here, this minus 2, suddenly I wrote this minus 2 over here. See, minus sign does not belong to numerator or denominator. It belongs to the overall number. Okay, so actual way of writing is like this. Okay, but we end up becoming so possessive that wherever the numerator's negative goes, we send it along with it to denominator. If it is going elsewhere, we send it elsewhere also. But overall, it belongs to the number. Okay, and it doesn't belong to a particular numerator or denominator. So whether I write minus 3 by 2, or I write 3 by minus 2, or I write minus 3 by 2, they all are same thing. but this is the actual correct notation of writing this kind of questions. Okay, now let us try one more question. Okay, 25 into t to the power minus 4 divided by 5 to the power minus 3 into 10 into t to the power minus 8. Okay. How do we solve this kind of questions? See, wherever there is variable, try to take the variables on one side, either numerator or denominator, and the number part also try to keep them on one side. Okay, so this can be written as, see, the moment we see 25 or any number, try to simplify it to prime factors. Prime factors are those numbers which cannot further be divided and are the factors of this particular number itself. So 25 we know is 5 square into t to the power minus 4 divided by 5 to the power minus 3, and 10 can be written as 2 into 5 and t to the power minus 8. Okay, so this 5 to the power minus 3 goes up and this 5 will also go up. So ultimately what will it become? 5 to the power 2, and this goes from numerator to denominator, so the power sign changes to plus, and this one was having power 1, which becomes minus 1 over here, into t to the power minus 4, and where do we find t? This t goes up and it becomes plus 8 divided by 2. We could have taken the 2 also upward, but it's okay. Let somebody be downstairs also. So what do we get? 2 plus 3 is 5, minus 1, 4. This becomes minus 4 plus 8 is 4 divided by 2. At this stage, it's always better to either simplify it or let it be in this stage also if you do not have much of a time. If you have too much of time, then do 5, 5, 25, 25, 6, 25, 1, 2, 6, 5, 1, all those things. Okay. Otherwise, it's perfectly okay to leave it at this stage if you do not have much of time. Okay. Now, one important thing I want to ask you all right now. We know 1 to the power 2 is what? 1. We know 1 to the power 5 is also 1. Now we know 1 is equal to 1. So we can say 1 to the power 2 is equal to 1 to the power 5. Will that mean, since the bases are same, the powers can be equated and it becomes 2 is equal to 5? Will this rule hold or not? Now, this rule that I told, that when the bases are same, the powers can be equated, holds true for any value except 1 itself. Apart from 1 and 0, for any other value, this will hold true. So here we end the class for today. If you have any doubts, please feel free to ask me. Thank you everyone for giving your time.